Anyone is?
Yeah, just as a repeat, we start at 12, but you can already download the materials.
Yeah, the material download.
For the session. Yeah, just to repeat for the people that might joined remotely.
Any help you need, you can let me know. There will be 2 folders and 1 presentation. Okay, so everything can be downloaded. Okay. So since this is a tutorial talk, so I would just expect that you complete something by the end of the talk. Okay, and I won't be going through all the presentations. So my target will be that at the end of the day, means after this particular session, you can do something out of that. So hope you will please cooperate. So the downloading is required. Are people joining from remote also?
This I can't tell, but most probably. Yeah.
No problem. Okay.
We can check on the Discord channel.
Okay. So, if anyone has downloaded, it's successful in downloading all the stuff. So there are 3 components. No? One will be a folder that's called, one will be that source code files will be there, but it's renamed as .txt file. So if you want to run those code, one small thing you'll have to do, just rename it to .py, okay? But don't have to run right now. Achha, now there will be a presentation deck. Have you received that? A presentation deck, the entire presentation is there, okay? So you may simply browse the presentation and sometimes listen, sometimes don't listen, not a problem. And another folder is there. That folder is called, basically that folder is called MP3 downloader from YouTube. Something like that is there? It's there? Okay. So if you have got that MP3 downloader from YouTube, there you will see one .py file, okay? Another you will see a text file, okay? Another you will see a text file, and then if you open the text file, you will see actually name of few songs, but those are Indian songs, okay? So might makes less sense right now, but whatever it may be, that is the name of some songs. And another will be a folder. The name of the folder is what? Can anybody tell me? In that MP3 downloader from YouTube, there is a folder also. Downloaded songs, na? Downloaded songs, there is a folder, na? But it is empty. That is empty. So, let me tell you the end of the story. The end of the story is that this is basically your assignment, and we will have lunch only if this assignment is completed. That I think, because that is YouTube download, it's not a small thing, okay? Okay, so now what I have already written some code over there in that py file. If you open, you will see some code is there, and some that input file is also there where you can put name of the songs, and the folder is also there where we can download the stuff. Okay, everything is there. So you need to do a bit of enhancement. Okay, so that will be the assignment, final goal. But what are those enhancements? To understand that, we need to go through the presentation a bit. Clear?
Okay.
Yeah.
Yeah, then also from my side, warm welcome to the tutorial session on inter-process communication and synchronization. Yeah, a small reminder, It is very helpful if you ask the questions still in the tutorial line, or like I will look around and see if someone has a question and then just pass on the microphone, because otherwise it's neither on the recording nor can people remotely hear your question. So that would be really great if we can be in sync with that. And then looking forward to your
Tanmoy.
talk. Yeah, sorry, yeah. Then
Tanmoy. Tanmoy.
Tanmoy. Yeah.
Okay. So
Looking
you, whatever you like, it is just a set of characters. No? You can call me any name.
Pardon?
But we are actually in Python, na? It's just a set of characters. You call me any name. What's there in a name? Tanmoy. Tanmoy, and surname is Bandyopadhyay. Okay, that's basically Indian name plus surname. Okay, so that's the thing. I'm telling that is nothing but in Python a sequence of characters. Okay, so you can call me any name. Okay, so nothing serious. Don't worry. Okay. I talk in that manner.
Okay.
Okay, so programming and all those things
Tanmoy.
are fun. Okay, so what he told actually, Ralph, your name please once more?
My name?
Yeah.
I'm Lucas.
Lucas. Okay, what Lucas actually told yesterday, I came to know that I will have to stand over here most of the time. Okay, so since camera will be focusing this area, so and they want to, organization just want to record this session so that this can be reused and people can take some benefit out of that. So I won't be moving that much, okay, because they told me. So, and so that means, and as Lucas told, that you can ask the questions, okay, a little bit louder so that it's audible to everybody, and people who might be using the recording can also hear those things, okay? So that's basically the key point. And so now we are starting the presentation, and so now, so this is done. Shall I minimize it? I can minimize it. Okay. So now, the fact is that while I was preparing the presentation, then finally I understood that it's going to be long. Okay, it's going to be long. And all the concepts are, these are nothing difficult concepts, but the only thing is that it requires a little bit of prerequisites, okay? So, that prerequisite, because in this particular audience, any audience, so some people are computer science people, some people are maybe electronics people, some people can do, say, are expert in data analytics and those things, okay? So it's basically, I believe it's a mixed audience, okay? So everybody may not be having that prerequisite, okay? Am I clear? So a little bit of yes, no from your side will help me to understand, okay? So I think, so that means what I will do, I won't go through one after one, these 30 slides, okay? What I will do, I have already given you the slides, okay? As and when I will tell you the basic points, okay, core things, so that everybody can understand. And if you see this one, if I now just open my presentation, okay, so you will see that the next slide, if I go, this is basically the content, okay? And after that, there is a slide which is having a set of questions, that is the prerequisites, okay? So I won't go through everything on that prerequisite. It's quite pretty big, but I would suggest that you go through, so let me show you once, okay? So these are the prerequisites, a lot of questions are there. You have everything. So you can go through those while we are discussing, and then you can ask me questions, and what I will do, I will choose a basic set from that and move ahead. Okay, that's fine? Okay. So here, let's see what we are going to discuss. Now it's IPC and synchronization techniques using Python will be explained in this tutorial. So what's the full form of IPC? Very good, inter-process communication. Inter-process communication, okay. Now, to one very basic question. Do we use inter-process communication every day? The question is, do we use inter-process communication? Forget about Python, okay? So in any operating system. So do we use IPC techniques every day? Are we aware that we are using? Can anybody name me the most common IPC that all of you use perhaps every day? Shall I repeat the question? The most common IPC that all of you use perhaps every day. Maybe, yeah. Huh? Pipe. Very good, pipe. You work in Linux. Okay, but people who do not work in Linux do not use pipe. Thank you. Anyone can give me a inter-process communication that the most common form of IPC that I am sure every day you use, but we may not be aware, though that IPC we won't be covering in this particular tutorial. That is a separate class altogether. Anybody? Hmm? Who told socket? Very good. Very good. Socket. So he told socket. So do you agree? If you agree, then you will have to clarify this, that in what context. I want a layman to understand that particular context. He told sockets, okay, but socket is again a computer science term. So I need you to just understand that what's the, for a layman, what is that socket? This example is perfect. Just I want a little bit of higher level abstraction of that example. The name of the application.
Web browser.
Excellent. That is a web browser. So a web browser, every day we are browsing Google or any website, okay? So that web browser in your machine is a process. It communicates with another process. So what is that another process? That is basically your web server. So your web browser communicates with your web server, and basically you can view the web pages. So this is also a form of inter-process communication, but this is basically a bit sophisticated inter-process communication. Why? Because here the processes are the web browser and your HTTP server. They are not in the same machine typically. They are across the network, and there are different protocols are involved. You must or may have heard that TCP IP protocol suite, so those things are involved. But this is one of the most common form of IPC, inter-process communication, that we use every day. And apart from that, as he mentioned, that while you are using Linux-like operating systems, then you use pipe, okay? Daily work, if you want to count the number of users who have logged in. So I write who, then pipe, then WC minus L. So pipe is a form of inter-process communication, who and word count program, and you get the output that how many users are logged in. Okay, that's another common example. Other examples are, there are many examples. Other examples are within any, say, any devices, the processes are there, any type of devices, your mobile phone or maybe router and all, they communicate with each other with the help of inter-process communication techniques. Okay, but we are not going to cover those devices and all the things, but the key point is that that's a very important aspect, IPC. Okay, so, and synchronization techniques. Synchronization technique means that, say, it's a broad term. It's a very broad term actually. It means that, say, in a banking application, okay, you are withdrawing money from your bank. So basically, you are trying to you are trying to withdraw money, and finally the bank's database will be updated by your withdrawal. Okay, but at the same time, maybe your brother is also trying to do that with your account credentials. Okay, so now what will finally happen? So will everything be messed up, or finally you will get a perfect result that okay, you have withdrawn say 10 euros and your 20 euros, and finally your balance finally shows that your account is 30 euros now, and you are poorer by 30 euros, something like that, or will it be something else? Will it be messed up that say instead of getting 30 euros withdrawn, maybe 30 euros got added? Okay, so somehow or the other, so that will be a good thing for us, but that should not happen as per computer science principle. So that means that somehow or the other, these multiple processes, I'm considering users as right now processes, okay, that will be browsers also, there will be processes on the server side also. Okay, so they need to sync. Sync means what? They are basically accessing a single DB. DB means what? Database. Okay, so and the database is getting updated, but there are several processes trying to access the database and update it. So we will have to ensure that the updation is done properly. No, say it's mutually exclusive, so that when one person has updated it, at the same point of time, in the middle, other person won't update it. So it's an example of synchronization. There are several examples of synchronization. So that's a general synchronization. And so that's basically the thing that that interprocess communication, how we communicate. I have given the example of the broader example of a socket. Then I will come to these smaller things little bit later, and then say your synchronization techniques. And in the middle, we have another topic called say, by the way, what is a process? Can anybody define what exactly is a process? There is a definition.
It's an application running in its own memory space.
Very good. An application which is running in its own memory space. So if that be the process, then what is a thread? Little bit louder.
It's a part of an application running in the same memory space.
It's in the same memory space as
The process that created the thread.
exactly. So what he wanted to say that it's basically a bigger entity process, okay, which is a program in the state of execution, and it can so I can consider that this is a process, one process, but for efficiency or for some other reasons, okay, we have also come up to a concept called thread. Thread, okay. The thread means what? It's a bit lightweight. Lightweight means creating a process, though we don't know what the operating system does right now, okay, but creating a process will take some overhead, and creating a thread from that process will take far less overhead. Okay, overhead in terms of say operations done, memory space required, etc., etc. So basically what? One bigger process can spawn several threads, okay, and then several threads can do some sub activities, okay. So that's basically the concept of process and thread. Something between them is shared and something between them is not shared. But one important thing is that process 1, process 2, process 3, by operating system design, they are separate entities. You got the point? I have a process. So now, if I consider, say, the browsers, okay, you can open several instances of the browser, okay, but see, you can browse Google through one browser instance. You can browse Google through another browser instance also. But the data of this instance doesn't get messed up with the data of the other browser. So basically, they are distinct. So now, let's not complicate that whether it is a process or a thread, okay, but they are unique things, having their say own memory space, but operating system will actually say optimize and make them thread and something like that. But one thing we need to remember that the threads share some part of the memory, the data and the heap, those type of memories. So inter-thread communication is perhaps simpler than process. Why? Because processes are inherently separate. They are virtual memory address space of one process, another process. These things are separate. So communicating between the processes will be a bit challenging compared to thread. Okay? There are lot of technicalities, APIs and all those things that you can go through in Python also, in C language also, but in simple terms, that's basically the big picture. And in this particular tutorial, I am mainly focusing on processes. Okay? Achha, just one question. Anybody knows, even if you do not know, not a problem, anybody knows the system call to create a process in a Linux-like operating system? Fork, very good. So how many people are aware of the fork? Very good. So fork is the system call to create a process in Linux-like operating system. Okay, so but I don't need that prerequisite. Something will be different in Windows. Okay, now all these APIs and all what we are going to discuss, these should work on all operating systems. This should work on all operating systems, but the behavior can be a bit different. Okay, why? Because these higher level APIs actually call the operating system calls or routines. So the behavior can be different and something may not be supported in Linux or in Windows, something like that. Okay, so you need to little bit check these things. For my case, I have run these codes in Windows operating system. Okay, so many of you are having Linux operating system. I would have used Linux operating system, but since this is my office machine, I could not download it. So I have used the Anaconda, that is the Spider, over Windows. Okay. Now this is basically our TOC. Now let's quickly see that. So three components we are going to talk. First, process, simple way how to create a process. After that, we will go to inter-process communication techniques. In the middle, we will go to sharing state between processes. And at the end, we will go to what? Synchronization between processes. And you will end it up by doing that assignment. Clear? So this is C and simple example of creating a process. So what happens is that it's basically def main and all those things are not required actually. It's just for I have written the code in a little bit of a readable so that it becomes a bit readable. So here you see if I run this piece of code, basically I will be having two processes. One process is the main, that is the first process, okay, and that particular process is creating another child process, which is called, it's no name right now I have given, but it will try to see the basic idea, people who are new to this one. Target equals to start function, that is important. So basically what? Initially the code will flow from main, this line will come at first, no, underscore underscore name equals to underscore underscore main, then main is getting called, okay, and what does main do? Whenever main is getting called, one process is already created. That is your what process? Parent process. Okay? And after that, one child process gets created. How it gets created? Here in Python, we are not using any specific system call. People told that fork is a system call in Linux. There can be other system calls also, vfork, etc. And in Windows, there will be some other API. But now the things become simple. I just call the process constructor. I give the starting function, that what that process will do. What that process will do in this particular case, do nothing as such. It will print hello, and it will take an argument, that is the name. In this particular case, the argument is what? PyConDE 2020. And if you see that that join, there is a call called join. Okay, join. And you see that one join is, a join means what? Basically in this piece of code, simple piece of code, there are two processes. One is the parent, and there is the child who got created using that constructor. Okay? And this join call will basically wait. Wait for what? Wait for the termination of the child. Okay, so two complete processes got created. It's a very basic, simple code. So what you are going to remember, that we need not have to worry about specific APIs for operating system. I can simply use the process, I can simply use the multi-processing package and then create process. Okay, and I need to give the starting function of the process. Same thing for thread also. You need to give the starting function, but we are not talking of the thread that much in this tutorial. Process, so a complete process got created. I may now, after that the process will do something after the starting of the process. So it does, in this particular case, it simply prints hello world, okay, hello PyConDE 2022. And in complex cases, it can do a lot of stuff. And then if I want to wait for the process, wait for the process's completion, then I can call the join function. Clear? So this is a very basic thing. Why this is required is that this is the very basic thing. So let me just once just run the code. Okay, so here it's basically nothing. It is basically Py. Okay, let me just once. So it has printed the result, but the only thing is that I am using it in command prompt. I have seen that in Windows, the Anaconda, while I am using the system calls, the Anaconda is not behaving properly. For that reason, I use the command prompt, and instead of that, I could have used this Anaconda. This is basically the Anaconda distribution. Okay, I am using it, and Python version should be 3.8 plus. So whatever you have, it should work. Okay. Now, so this is fine, but I need another thing, is that for you to take a note of that, because we will need it for the assignment. So I need you. So this is, I have not taken in the slide actually. This is an important thing. Here there is a, how many processes I have created? I have not put it in the PPT, it's just from the python.org, okay. So how many processes I have created in the earlier example? One process only, total 2, but explicitly I have created 1. Now, suppose it's basically our purpose is what? To make things fast. To make things fast, I need to download songs from YouTube, okay. So what I can do? I can do it one after the another, and I can run a loop. Okay, somehow or the other, say a loop is running, and then somehow I'm trying to download one song and got the output, and then I'm fine. Then I go back to the end of the loop, try to download another song, something like that. Okay, how, that we will see. But this is inherently sequential. Sequential means what? Parallelism. I need to have n number of processors, okay. So that's, I'm not talking of that, because our processors are also limited over here. Means basically I can have, I think at max what in my machine it should be 2 cores or something like that. But to make the things a little bit, so what I can do here, okay, but at least pseudo parallelism I can get, pseudo parallelism, okay, Shan? We won't get, na? Why? Because your processor is basically, earlier days the processor was limited to 1. So what we used to achieve is multi-programming, that or pseudo parallelism, round robin thing, time sharing, and all those things we used to do. Okay, here say in an iterative loop, if I run and try to download the stuff, then I can go get stuck at some point, na? Some error is there and they cannot move or something like that. What I do, I spawn in number of processes, and I give that sung to n, so sung to one process, another to another process, something like that, and let them work. And then somehow we will try to get back the data. Okay, I have not done it. You need to do it. Okay, in my version of the code, it's basically iteration, but I would like you, when we have learned that it will be several processes, and several processes, one will be downloading one song, and possibly we will be able to make a robust code in terms of error handling and perhaps faster response. For that, we need to know a very simple thing that is called pool. We have learned process. One process we have created, and now I can create definitely in a for loop, I can create 100 processes using that process constructor. But there is a new thing. This is called pool, P-O-O-L. And what is this? Processes equals to 4. So there are a lot of syntax and all those things, okay? So let's not worry about those lot of syntax and lot of syntax right now. You can read it offline. But basically, pool with pool as pool. So this width, anybody is aware of this width statement? Width statement is basically what? Width statement, anyone is aware?
It's a context manager.
Yeah, exactly.
And it's meant to clean up automatically when you leave that block.
Great, thank you so much. So it's a context manager. So the cleanup means the whatever memory and all those things are there. So cleanup will be done automatically. Okay, so that is the plus point of using a context manager. Okay, as he mentioned. Thank you, sir. So then processes equals to 4. That means here 4 processes, and I have created processes. And now what the processes will basically do? So you need to know what you learned. Processes should have a starting code, starting function. No? Starting function, in my earlier simple example, I have given you that starting function. In this particular thing, the starting function is basically f. And what is f doing? As such, not a very big thing, return x square. Okay, and so there are 4 processes, at max it will be created. And what's the length of your job? Length of your total job? It's basically range 10. So range 10 means what? It will generate 10 numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should correct me, huh? Every day I don't write Python. I have, so if I tell something wrong, please correct me. Okay, so that means what? You create 4 processes at one go, and your library will ensure that 10 numbers are getting processed by 4 processes. So it can happen what? It can happen one single process, one number, then second process, second number, third process, etc. And they will circulate something like that. Okay, so I could have made 10 processes also. Okay, so got the idea, the process pool. So it's the expectation that, so it's not exactly iterative, that in a for loop I am running 10 numbers, but it's somewhat parallel, that 4 processes are there, and one process can do 2 tasks also. That is basically, it can return the square of 0 also, 1 also, 2 also, but the library will appropriately balance the load. Clear? That means with the pool, you need to use this pool. With the pool, you can spawn multiple processes at one go. The maximum number you can specify. There are other syntactical things also. And you can do your work in a, again, parallel manner, means parallel in the term of our parallelism, okay? So that not exactly parallel, but pseudo parallel. So is this clear concept? Pool? Take a note of that. Okay, very good. Thank you. The URL, I think you can simply see now that URL. I have not. Maybe you can just check it out and open it because you need to use. Okay. Process pool you have learned. Now, what we are going to learn, the IPC techniques. Okay. So IPC is simply, see, I can have a pipe IPC. Okay. Pipe. It's a very simple IPC pipe, and I can have a message, queue type of IPC. So let me first show you. I can have a pipe, I can have a queue. Okay. Now pipe we have mostly used like this, as he mentioned in Linux we have used that pipe IPC, and queue also can be used in different applications. So the basic difference is what? Basic difference is basically pipe is basically what? Stream of data. Okay, no format as such is there, not exactly message boundaries are there, and in say queue I will be having some message boundary, and the queue's features or queue's say thing will be implemented. So I have examples. So quickly tell you a simple example of a pipe. In this, from this particular case, let me explain you this one. Now, normally we don't have to use these things in day-to-day life, okay, normally, but still, using system call, what you have done, pipe call. Pipe call returns two ends. You can see, na? One end is called means I have written the variable name, read end and write end. After this, what happens? You go see to me. One pipe has been created, first call, pipe. And what is that pipe? It's, and we consider one-way data transmission, not duplex. I can have duplex, but let's make things simple. One-way data transmission. Two ends are there, two end, read end and write end. Okay? After that, a process got created. Now what happens? My first hand, the parent process, okay, created a pipe. After that process call, another process got created. Two independent processes got created. Okay? Pipe is having two ends, read end, write end. So first left hand having read end, write end, second hand having also read and write end, same pipe. Okay? I need to communicate between say parent and the child. And in this particular case, I can see that the child is basically writing to the pipe and the parent is reading from that pipe. Okay, that's what it's doing, na? That child process args equals to write end, child process dot start and parent read end. What the parent does? The parent calls a function receive, it will get the data, and what the parent will do, what the child will do, it will simply print something on that pipe write end. So that's what a pipe is. Again repeating, pipe, simple IPC technique, no as such message boundaries. Whatever you are putting, it's first in, first out type of thing. Now, you create a pipe, it is having two end. One is the read end, another is the write end, and the left hand side will be the read end, right hand, and that next one will be the right end. Please remember that. Okay, in that manual page, you will see that in this manner it's written con1 and con2 in the manual page, and you can understand that this is also written that con1 can only be used for receiving messages and con2 can only be used for sending messages, considering a unidirectional pipe. So here, so that's pipe. Only thing is that here I have not written I would have done something that, what would I have done? The child, basically the things are getting duplicated. This is a very key point. People who have used fork call, they know. It means what? This read end and write end, those were initially created in the memory space of parent. But whenever you create a child, those things got duplicated. So both ends are.
Sorry, Tanmoy, could you maximize your presentation? Could you put it on full screen? Then it's easier to read. Just comment. Thanks.
Fine, huh?
Yeah.
So what happens that we have the read end and the write end, and those got duplicated. Please remember this particular point. So sometimes there can be some scenarios where the data transfer is not properly happening. Why not properly happening is that if you are having redundant ends in this particular code, the child process only needs the right end of the pipe, and the parent process only needs the read end of the pipe. But for this code, I have not taken any special precaution because I am just sending a small amount of information. Okay, but say if it were a lot of information I am sending, at some point of time it can happen that I don't know, the receiver will not be able to know that say when the end will come. Okay, so it's a little bit tricky. So in this particular example, there will be no problem. I have not closed the ends properly. I have kept all the ends open. Okay, but please take a note of that. If you get some type of scenarios, you will be able to understand that. That basic point is that close the ends which are unused properly. In this piece of code, I would have written in that child, or rather I have actually done it properly. So child end, and if I write that send, okay, and even if, so I have written it here, but say in this small piece of code, if I omit this statement also, then also the code will work perfectly fine if I don't close the end. But in some cases where you are sending, say, long streams of data, at that point, the other side who is receiving that won't be able to understand that when he is going to stop. Okay.
And this is already some synchronization, I guess.
It's already, yes. So just think on it if you have any question. Yes, it is already synchronized automatically. You will see that this code means it's perfectly synchronized actually. Because why it is synchronized, your question I understood. It is synchronized because, see, parent read end, that line is at the end of the main code. So the parent process will actually stop over there till the time the child process writes data. So this code, I don't have to do any specific synchronization. It's actually synchronized. But in some cases, I need to do something. Is the question answered? We might come to these things if we have time. Okay, let me now skip a bit. Okay. So as I told you that this one I will show the code actually coming to the queue. Okay. So queue will be similar to pipe, but it gives you it's a queue actually. So the APIs are different, okay, and message boundaries are there in that queue. So that is basically a functional requirement of a piece of code which is little bit bigger than that pipe code. I am using a queue in this particular case. Again, inter-process communication because I am creating multiple children from that main process. So, and they will communicate, and this is basically with the help of queue. So what's the functional requirement? Process is created. A process shared queue is created, okay. So process shared queue. Pipe was also process shared by default. This queue is process shared by default. So these are the IPCs. Why? Because two processes, as we discussed initially, they don't share anything. They are by default distinct by the operating system design, but in these cases, these things are shared. So multiple processes can use that queue, okay? A log file is created, just to make it a little bit more complex. A log file is created, few more processes are then created from the initial process. Now you know how I can create few more processes by using the process constructor, okay? The queue is updated with some information by all the processes, okay? The parent process waits for the completion of its children. How it can wait for the completion of its children? By using which call? Join. Very good, by using the join call. The parent process reads all the entries from the queue, okay? The parent process updates the log file with the entries of the queue, and the parent process exits, okay? So little bit bigger piece of code with all the component. One log file is also there. Why I have given that log file? Because you might be needing to use a log file for logging errors or information, something like that. So if I go through the code quickly, just give me a while. So this is the you also have the code, okay? Now this logging and all those things are extra. It is just that it's not exactly I thought to cover all those things, but just if you don't know, you can use this construct. So intentionally I have put these complexities in the code, okay? So basically what it is doing, so logger and all, so I am creating a queue over here, okay? You can browse the code. Now here I am creating some processes. How many processes I am creating? I am creating basically few processes, 5 processes I am creating. You now know this one, and I am keeping those processes in a list just to show you a bit of. So in a list I am keeping these process descriptors. After that I am starting those processes, and you need to have a starting function, na? So what is that starting function? Name of the starting function? It's basically update queue. So what the queues, what the processes are doing, they are writing that their PID and their parent PPID thing, means that parent process ID. So parent process ID of all these processes basically will be the same, na? Okay. And they are updating those things. One thing, please take a note. Here, I don't need to protect the queue as such. This is the plus point. These are automatically protect. Protect means what? That while you are putting something in that queue, if another process also tries to put something in that queue at the same point of time, then what can happen? The data can be mixed up. But I need not have to worry about that. The data won't be mixed up. The queue is implemented in that particular manner, because here you are not using a single process. Here it is a bit complicated. Why? Because there are several processes. Here I am basically here I am creating what? I am creating 5 processes, and 5 processes they are getting that queue, and the queue was created in the parent process. The parent process then creates those 5 processes. The queue now is shared, one queue. And it can happen what? While you are putting something in that queue, he also at the same point of time in the same slot, he also wants to put something in that same slot. At that time what? Typical example of race condition. But in this case, these are handled by the API. I don't have to do anything special for this one. So this is the plus point. So that means what? And after that, the main process, parent process waits for all the children, okay, by using the join call. And now that queue empty and these functions, please read it, okay, once offline, that the queue, all the APIs are there, and There are little bit of different type of queues are also there, simple queue, joinable queue, those things, okay? But the basic thing is like that. So the parent process is getting one after the another, and then what it is doing, it's putting it in the log file. So your code will work fine if you, so what I can show you once quickly running the code here. This is basically my log file. This is basically my log file is empty. Okay. Now hopefully it will run. Okay. If it doesn't run, it is to be kept as an assignment. Python then what was the name? Process underscore Q, or what was the name? Multiprocessing underscore Q. Okay. Oh, great. It has logged successfully. What it has logged? So quickly. IPC log. See. Okay. Here it's fine, okay, child 0, child 1, 2, 3, 4. So as usual, 5 processes got created and everybody is logging its parent ID, that is basically will be same as that of the main process. So everybody's parent ID is the same 20332. And this one is the parent. The basically this printout, it came from the parent, and the logged information, this child 0, 1, 2, 3, 4, this was written by the child processes. So as per the log, I can see that the things worked fine in this particular case. Okay, so what we learned that a little bit of log file, okay, it might be required, you can simply use it. And I can see here, I can see that the PPID, parent process ID, is also the same for these 5 people. And this one is basically the interpreter's ID. And this is the main process which created your 5 children. Okay. Anybody was able to run this code successfully apart from me? Making, it is running. Anybody run it in Linux? It's running. The code flow, you are able to understand the code flow. Okay, very good. That code is working. So this you have understood, but I have not used any lock here. Why I have not used any lock on something like that for synchronization? Because the queue is inherently made in that particular manner. Okay. So now let me, okay, thank you then. Listeners and client, okay. I am telling you the basic idea, and you can run the code yourself. Now, listeners and clients here, it's actually, see, it's basically, we can use queues and pipes, okay, that is fine. But a bit of higher level flexibility is given. Higher level flexibility is given in the sense that these 2 pieces of code, or in that module, multiprocessing.connection module, it actually gives you the APIs, higher level APIs, which are like socket. Okay, which are like socket. Now, what's the meaning of that? Socket typically is used between 2 processes which are separated across the network, but I can run it in a single machine also. And what it will do, you will have a client piece of code and you will have a server piece of code. Okay, HTTP, that what example we were taking, na, browser and HTTP server. The HTTP server is constantly running. Okay, in this example, now I am not using the socket module exactly, but I am using the connection, that multiprocessing, that connection module. It gives you, means we have seen pipes and queues, and this one is basically also giving you the similar features to that of socket. Okay, but I could have used specific module for sockets which give me more low level power. Okay, but this one also is fine. Okay, so what basically, there are two code, that code and this code. One code is the client, another code is the server. Okay, even if not everybody understands, you see that the server code is having an infinite loop. Okay, infinite loop is there, and the client code is not having any infinite loop. Now the server is always running. So when you are running this piece of code, which code you will have to run first? The server. And after that the client you will have to run. Okay? And how the client and the server is getting connected. Now basically, one IP address and port number funda is there. In this particular case, the IP address is not exactly mentioned any IP address, but we are using localhost. And what is that port number? 39359. Nothing, nothing special in that number, my employee ID. Okay, I have used it. So, and so this is basically the server piece of code. And whenever the client connects, the server will receive that connection request. So if somebody knows TCP, transmission control protocol, what happens? There are three parts. Okay, the client sends connection request, three-way handshaking goes on, after that data transfer goes on, after that connection gets closed. So lower level details, it's a protocol in TCP IP protocol suite, but that is a lower level, but those things are getting, say, implemented here. So with this small piece of code, you are able to actually design a client server program. Okay, so that one is the server. You can simply change now. You can simply change the port number over there. You can use your employee ID or any arbitrary thing, but little bit use a bigger number, like 30,000, 40,000, or the smaller numbers are actually reserved sometimes. And this is the client piece of code. And these features are also given by that module, that authorization key, some password I can pass. So these are hard coded. We can do some sophistication with that, you can read. But in nutshell, very quickly we are able to design a client server piece of code with the help of multiprocessing.connection module. I am not running this piece of code. Anybody can run this piece of code and tell me if it is working or not. How to run this piece of code? First you need to take you need two windows. You need two windows. Na? In one window, first you run the server, and in another window you need to run the client, and there you will see what the data transfer goes on. If you need me to run the code, I can run, but I'm giving it to you. I believe you are not getting tired, na? Huh? Please run the code and tell me the feedback. Or if you tell me to run, I can run it also. So this is not the socket module. I could have used the socket module also, but this module quickly gives similar features. Okay? You can simply change, this one is, oh, you liked it?
Yeah, also it works, I think.
Achha, it is running also.
It's running, yeah.
So can you just change the bit of port number and just see, and you can change the, means a little bit of change, then things are running or breaking? Running.
Server breaks if you enter a wrong password on the client.
Oh, it's breaking, na? If you are breaking it, you will have to fix it. Take it as an answer. Okay. So, but server is in an infinite loop. So anybody, can you tell me that if you have written any server client code, what type of server is that? It's a very bad server actually. It's an iterative server. iterative server. One by one, client 1, if it gets blocked, the server can't proceed. Why? Just see the loop, while true loop. And this part actually, okay? So that 3 lines, that while listener dot accept as con, that 3 lines, those can get blocked actually. So professionally, when we are writing, we won't be writing such a poor server. This is basically an iterative server. The clients are getting served one after the another. See, first loop is fine, that while true loop. What is the meaning of that while true loop? Your server will always be on. That is okay. But inside that with listener.accept as con, what is the meaning of that? It basically means the TCP's accept call is getting, accept call waits for connection from the other side. So the accept call is waiting, then it does some work. So these 3 lines are what? Print, con.send and all. These 3 lines, last 3 lines are basically the work. But those 3 work can actually, while the server is doing those three activity, the server is blocked. So while you are writing a production server, you won't be writing in that manner. Possibly what you will be writing? You will be writing, say, after that accept call, you can create separate threads to handle that specific client. Okay, something like that, but that's not a topic right now. So this is a very simple server, which is an iterative server. You can take a note of that, iterative server. And in productions, you write what? That is called technically concurrent server. Concurrent server. Okay, and concurrent servers, there are different ways of designing it, using thread, using processes. Little bit now you can understand that instead of doing the 3 activity here, I could have spawned a process, or I could have spawned a thread and do those things in parallel. Clear? Okay. So finally it was running. Sharing state between processes, shared memory, server process. So it's basically shared, as I told you, that now I want to share some data where other person can read that data, okay? Other process can read that data. Inside the thread, it becomes easy. Why? The thread, I can put something in that global data area while we are doing a multi-threaded programming, and the threads can read from there. But while you are having separate processes, it becomes difficult. Why? Because those are inherently separated, okay? So these 2 things are simple. I will rather take it up. So this is basically one way shared memory, another way server process, 2 simple things. I will rather take it up a little bit interesting thing. You can read these slides. Those are very simple, and I will little bit take it up. A new thing, which is a newer implementation, which is which actually tries to imitate the earlier System 5 IPC. Earlier System 5 means, first there was Linux or Unix or Linux, okay, I'm considering now Linux. They had that older implementation of system call implementation of System 5 IPC. You have POSIX IPCs also, with the help of C, CPP, etc. You can do a lot of things with that. But so Python came after that. So Python used those those APIs, system calls, and they created their own wrappers, what we are seeing. Na? But inside those wrappers, the operating system primitives will be there. Okay? So this one is a bit newer implementation of a shared memory, which was already there in Linux. So I have written that is a System 5 style shared memory blocks. You can just check, I think, from Python version 3.8 plus, I think this was given. Okay, so key point is what? The key point is, say, let me now show you the code. This is basically what happens. One shared memory will be available so that all processes can access it. And if it is a shared memory, it is very fast. It's actually very fast. Why? No specific API is required to access that particular shared memory. normal condition, process 1, process 2, process 3, nothing is shared. The memories are different. But in this case, by using the system 5 type of shared memory, I can have a memory part shared. So since this is a memory, not a queue, etc., so no specific complicated APIs are required to access that. So using shared memory is used in industry. So with the shared memory, you can achieve very fast communication. Okay, so with that example, what I think, let me see where. Okay, so let's just see the example. The example is that just quickly read it once. So which module I am using? Multiprocessing.shared memory module I am using, and then one process. So one process need to create a shared memory. You create it once. Anybody will have to create it. Okay? After that, whoever comes don't have to create it. They will simply, technically this is called, they will simply attach to that shared memory. So I have created it here, and now process 1 attaches, process 2 attaches, and the communication will be very fast. But you can well understand what is the problem. This is a shared memory. It's not inherently synchronized. Like locks are not there as in a queue internally. So you will get performance-wise faster communication, but you will have to do some sort of synchronization whenever required. So that is the minus point of shared memory. So with an example, so now you see in this particular case, I have used unrelated processes. Unrelated process means what? I am creating the process in a different window, okay, not by the process call. And the second process also updates the shared memory and it closes the shared memory handle, okay. The first process was polling, is just a loop. Shared memory for change of data, it then exits after it sees the change data in shared memory. Before exiting, the shared memory is closed. Now closed and unlinked, it is little bit different. Close means handle is getting closed. So by default, when the process exits, the handle means file handle type of thing, it gets closed. But you will have to explicitly make sure to unlink the shared memory or delete the shared memory. If you do not delete, it stays in the system. Okay, then it actually system by IPC. That was the that's basically, these are called what? Kernel persistent IPC objects. You will have to reboot the machine, then only they will go. If somebody has used, actually, there is a command in Linux called IPCS. Somebody must have used that. IPCS command, anyone has used? IPCS. If you have Linux, you can just simply type IPCS and you can see, possibly you will see 3 types of IPC objects. One is shared memory, another is semaphore, another is message queue. Just check it out once. IPCS, is it giving something? IPCS, or 3 things are empty. IPCS small in Linux. But you will get 3 entities. One is the shared memory, another is the semaphore, another is the message queue. But most likely you won't be having anything. But at least those 3 entries you are getting. With that IPCS command, if you run in Linux, you are getting something. And it can be empty. All the entities can be empty, but you are getting something. So basically, if you now create it and do not delete it, it will be there till the time you reboot the system or you explicitly delete it. So these IPC techniques are typically called what? Kernel persistent IPC techniques. Okay. Okay. So quickly now let's go with this particular code. You can run the code. You need 2 windows. Okay. Now see, the fact is that I have run it in, this can be an experimentation. I have run it in Windows. In Windows, even I do not know a lot of things, a lot of internals, okay? So you can try to see that if something is getting created or not as shared memory thing, okay, after running this piece of code. So this piece of code, now I'm telling you which one to run first, and just check the code first. Just see it here. This is the one underscore. So this code you will see that the shared memory's name is something like that. You can give a different name also. Okay? First listen for 1 minute. After that, creating the shared memory, and this first process simply update some value in that shared memory, arbitrary value. It's writing 22, 33, 44, 55, something like that, arbitrary value, okay? After that, this person is waiting. Waiting for what? Waiting for a value to get changed. Okay? So basically, if you are running this piece of code, in the first window you will be running this piece of code. So the shared memory gets created and some value is getting updated there, and this person waits for some other value. Okay? And who will update that value? Another process which is basically here. And just see the thing. This process is also similar, and the name of the shared memory is basically the same. So Python API gives you the feature to access shared memory with the name. Okay? And then this person, you will see that this person does that attachment to that existing shared memory, what I told you, and the first person did a create flag was true for the first person. Okay, so one person must create it, and even if the other persons now want to create it, they won't be created, they only will be able to attach to it. Okay, that makes sense. So the other person simply attaches to it and does some bookkeeping, and this person updates the value, that first value, with a 0. And at this point of time, the other person will, the first process will, he was actually checking in this particular loop, tightly he was checking, and at that point he will do that cleanup and exist. And what is that cleanup? It actually closes the handle like a file pointer and also does an unlink call. Unlink means it deletes, but you will see that in that second code I have not written that unlink call. Okay, why? Because if twice I will write that unlink call, what will happen? Then I will get an error. Now, before you run it, this particular piece of code, I have run it in Windows. Okay, now you are running it in Linux. Now I just need to check. Now I am telling of System 5 IPC, but I have not seen the implementation, that exactly how they are doing. So what I would suggest is that I have told you that IPCS command. So without running this piece of code, if you have run that IPCS command, you have seen the entries. There are no entries. I think you have seen no entries. Now what I would suggest, run the first code and then run that. Basically you need two windows. Okay, in one window run that first code, one underscore code. That means the shared memory gets created, and just check in that IPCS command that whether you are getting an entry or not. This I have not actually seen, but I have not experimented basically. I have run it in Windows, everything works perfectly fine, but I am not an expert on Windows internal, so I have not seen that shared memory internally getting created. So I just requesting you to check that whether in Linux that implementation is like that showing a shared memory is getting created with that IPCS command or no. If it is no also, then also it is fine. They could have used something else, but it should work. Have you got what I wanted to see?
So on Mac, the IPC is empty after I run the first command.
You have run the first code. Is it waiting in a loop?
Yeah, it's waiting in a loop, but IPCS doesn't show anything.
Sure. Understood. And if not showing anything. Okay. And if you run the second piece of code, is it working? Everything is working fine?
Yes.
No, the second one is saying that it cannot find the TB PyConDE. Like, there's no resource with that name.
What is the operating system?
Linux.
First code is working. First. Now, you will have to first run that one underscore code. There are two files. first you need to run that 1 underscore file, and in another window run that 2 underscore file. First you need to create the shared memory.
Yeah, but it's not being created.
Why? What it is telling?
So if I
No, let's not worry about IPCs. Even I am not sure how they are internally creating it. They can use something else also. They can use some memory mapping techniques also. Okay, just for a guess I told you to do it. I have not done it. So is the code working fine? That the code should work fine. If you run the code 1 and after that you need to run the code 2. Are those two things working fine?
Yeah, so when I run the first one, first it's waiting. Then I run the second one, and the first one is saying shared value updated to 0.
So it's actually working, but the only observation is that possibly their internal implementation doesn't uses the system 5 shared memory.
Yeah.
That's the thing.
So the second one is exits with an error.
Which one?
The second one exits with an error.
What is the error? In Linux, it is exiting with an error.
macOS.
What is the error? Can you just? What's the error? Can you just repeat once?
There appears to be one leaked shared memory object to clean up at shutdown.
Okay. Now error you have got, huh? Fix it now. It has worked in some. Okay, we'll check it out while we are doing the lab. Okay, another 10 minutes, 5-10 minutes I need. Okay. Coming to sync. Okay.
There's one question. What type of objects can be passed across processes? Are there differences for pipes and shared memory?
If you want to pass specific objects, in that object form, you rather should use that one I have skipped, you should use a manager. The manager gives you the feature to pass arbitrary objects, okay? But through pipe or shared memory in this particular manner, in the earlier shared memory, you can pass two simple type of objects. That is basically what? Value and array. I've skipped that. You can go back to the slide and see. There are two type of shared memory. One is I can pass value and array. Is a little bit of higher level abstraction, value and array only. And this one is basically a raw shared memory. So you will have to do everything on your own. And if you want to pass objects, then you should rather preferably use the manager. Okay. Achha. Coming to the synchronization primitives, there are several. Several means what? How many synchronization primitives are there? Many. Lock, semaphore, condition variable, then event, then barrier in Python context. So how many are there in Python context? Lock, semaphore, condition variable, event, and barrier. Explaining everything will take time. So let me tell you the differences between them, and everything is written. I will choose a good one to explain. Lock is actually what? Similar to, have anybody heard of something called mutex? Or maybe leave that. So lock is basically what? That you are using a shared database and you want to do some activity more than one process, and then race condition can occur. So what I do, I lock. So one process locks. After it completes that critical region, that means accessing that shared area, it releases the lock. And another process then can come and do something with that. So that's lock. Semaphore. Semaphore is basically gives you more features than a lock. So lock is having two states, locked and unlocked. So I have locked till the time I am going through some critical region, and I release the lock, and then another process or thread can access the critical region, does something, other process if it tries at that time, it won't be able to go. Okay, this simple thing, lock and unlock. But semaphore can give you some count, some count. Count means what? Suppose I want that this particular activity can be done by at max 3 persons, 3 processes, okay? So that count feature is not given in lock. Lock means exclusively I have the access. But semaphore, it gives you higher, it's a better abstraction that you can have a count. So I can restrict the count. Okay, so suppose 3 persons will do it. So at that time, I use it as a counting semaphore. But obviously, I can use the semaphore as a lock also. How? By using the initial value to be 1. Semaphore also I can use it as a lock. But for lock, I have a specific lock. But semaphore can give you more functionality compared to a lock. That means it can help you count the number of instances of any resources which are getting shared. Okay. Now next comes condition variable. Condition variable, it is bit complicated. Condition variable basically what? You have a lock, means exclusive access, okay, plus you have a signaling mechanism. 2 things are there. So you can lock some portion, some critical region, and moreover when you are done with it, you can automatically signal the other persons who are trying to access that. So that is condition variable. Okay. Now event. So event, if you are using condition variable, then event basically is becomes a bit of redundant. Why? Event actually gives you that feature to notify events. And so you can consider condition variable equals to lock, in simple terms, lock plus event. Okay. And the next one, which is also simpler, barrier. Barrier means suppose you have say 10 threads, okay, and you want that 10 threads must complete an activity and then only I will allow them to proceed. So you can set a barrier of 10 so that only if the 10 threads have completed, then you can cross the barrier. Then your means your application can cross the barrier. So that's basically a barrier. Again repeating, lock, simple lock, locked state, unlocked state, okay, for mutual exclusion, most widely used. Okay. Now comes semaphore. It's basically more functionality than a lock. It can help you count the number of resources. It can be used as a lock also by taking the initial value to be 1. Semaphore gone. Condition variable, it's the most complex one. It gives you features of mutual exclusion, means holding that thing, plus your notification that I have completed, you can proceed. Condition variable. After that, you have event. Event only notification. Okay. So conceptually, you can think of condition variable conceptually. There are nitty-gritty differences. Condition variable equals to lock plus event. Okay. And the last one is basically what? Barrier. It gives you a count, say 10. 10 threads wait for each other, and after 10 threads have completed, then only I will proceed. So that's barrier. So you can, so only 10 minutes is there. So any one topic, explaining any one topic will take more than 10 minutes. So what I would suggest that I have told you the theoretical things and I wait. So you can once for 2 minutes, you can browse the presentation and ask me the questions, the key point I have told about how many synchronization techniques? 5. 5 techniques you are not going to use in one day, na? Okay. But the idea, at least the theoretical thing, you can check it out from this particular slide while we are here, and then you can use, gradually you can use any one. So the lock is the so I'm telling you my example is that the lock is the simplest one. In the semaphore, intentionally I have not made the things complicated. I have used semaphore as a lock. So that is basically the lock example if you study once, and the semaphore example, both will be the same. Only thing, semaphore is used as a lock, but ideally I could have used semaphore for some other more activity, for some other activity also, counting the number of resources. So that's basically, friends, the story. Now, 9 minutes left. Complete the assignment. If you want me to explain anything in this time, I can explain. But just I want that you go to lunch at least with that MP3 downloader. And later also, you can ask me any question. Is there any, this water you can drink? This water you can drink. No, no problem, boss. It's work hard. Acha, in that music file, what I have shown actually, these are basically, I think by this time you have understood already. In this particular example, I have given the names of all Indian songs which I like. They are not nice songs. But for you, thank you so much. For you, these songs may not be that meaningful. So instead of these things, you can give some name of some songs which you like and just see. So what's the assignment tries to do? Make it a process pool, okay, and see what type of IPC techniques you can use to make it faster, okay. And little bit of installation is required, no? What is that? PyTube. PyTube installation is required. All said and done, if you cannot also optimize it within 9 minutes of time, 8 minutes now, I think.
Actually, lunch has started already.
No, that I know. Lunch has started. So, but means people are understand actually. They need that MP3 thing. So at least make the code work. With your songs, the things are getting downloaded, and then we can discuss. And before we break or you break, you can ask me any question. At least with that process pool, you can try. That though should work. Okay. In Linux, is that thing working? PyTube? That PyTube is working in Linux. Okay, you have installed.
Yeah.
It is the songs are getting downloaded.
Now we have wonderful playlist for weekend.
Achha, it's getting downloaded.
Yeah.
Oh, that's great. You can improve the code, obviously. Yes, I didn't work too hard on that, and time was also short. So please improve and share it with me. in Linux is that MP3 downloader is working. Will it be useful for you? The MP3 downloader. And are the songs playing? That is also one question. Acha, you have given it is still getting downloaded.
No, I got all of them. I mean, not all of them, there are some errors.
And that is okay. Some songs may not be downloaded, but it's not working. Working. That's working. And the songs are getting played. But that perfectly, when the MP3 is okay type. So, tell me whenever, yeah, we'll end it up. So, yeah, sure. So you are, thank you. Okay, so officially the time ends and I am ending the presentation with a big thanks to all of you. Okay, so I think you are busy in solving that program, and that is what is expected. And we can get connected. Given my LinkedIn profile, so please feel free to. Okay. So
Thanks for the tutorial, Tanmoy. I hope you enjoyed it and learned a lot. And as you said, yeah, if you have questions, I think there was nothing left on Slido last time I checked.
the questions can be, if any question is there,
yeah,
people can ask.
yeah.
Actually.
And then enjoy the rest of the PyCon. Thank you.
Thank you. Any question? Any question? I think solved, or every question solved. Or after
There was no online question. I can check again. No, at the moment there's no online question further.